than the plasma. Then the next one, I'll be taking these two together because they are almost the same, but it's just the only difference between them. This one is an archaic method. When you say archaic, that means it is what? Outdated. It is no longer used because of the complexity. Now, in the case of this, it is used to separate insoluble particles from liquids. This one is also used to separate insoluble particles from liquids. And how it does that is, in the case of decantation, you have a process like this, where you have a particular container containing, let's say, the solution. Then you have like a glass rod somewhere here. So how do you do it? You just pour that solution into this. The particles remain here while the liquid goes in. So it is used to separate insoluble particles from what? Liquids. Also filtration. Filtration is also used to separate insoluble particles from liquid. But the major difference between these two is that when you have a large sample, this one will definitely be what? Be rigorous. But when you have a large sample, this one will separate it effectively. This one is an inaccurate method of separation, while this one is an accurate and also modern. So they operate on the same concept, but the difference between them is that this one is archaic, and when you have a large sample, this one is inaccurate. So this one, it is used in water purification plants where you purify water. Although in this process, before this process is employed, you have how is water prepared to make it fit for drinking. There are some chemicals that are also introduced, like your potash alum to coagulate it. Then you have your chlorine to kill the germs. Then you have your iodine to prevent goiter before you know. But that's this the substances that are used here are also embedded in this filtration method. But I've been able to explain that filtration is more accurate than decantation. Now to talk about crystallization. In the case of crystallization, when you have a solution, so the first thing to do here is to subject that solution to heating. Why do you need to heat? When you heat, the heat is to evaporate some of the solvent in it. So when you now heat it, at a point, the solution is said to be saturated. The solution is said to be saturated when some of the solvents have been lost. So at that point, what you now have, some of the solvent has been lost. So at that point, when you now have a saturated solution, the next thing to do is to cool it. You subject it to what? Cooling. When you now cool it at a particular temperature, that's because as you subject this, you have crystals. You have, by the time you heat this, evaporating some of the solvents, you have a saturated solution. And when you now have a saturated solution, which you now subject to cooling at a particular temperature, because what you have, the substances that you have in this are salts. So, and each salt is very sensitive to its temperature. It's very unique to its temperature. And that is its unique temperature. That is where it will be separated from the solution as crystals. So that is the method of crystallization, and it is usually employed during the manufacture of sugar, in sugar production. So you can be asked in an exam that the process by which sugar is produced is known as crystallization. So you employ this in sugar production. Having talked about crystallization, there are some salts that are separated in the process, like your copper sulfate, pentahydrate, because this is meant for salt which decomposes on heating from their solution. And those salts that decompose on heating from their solution, you have this, that's copper 2 tetrasulfate 6 pentahydrate. You also have copper nitrate trihydrate, and you have iron 2 tetrasulfate 6 heptahydrate. So these are salts that can be separated by this process known as crystallization. So it's the process that is even designed for salts which decomposes on heating from their solution. Another effective one is fractional crystallization. Fractional crystallization. In fractional crystallization, it is more or less like a crystallization, but the difference between crystallization and fractional crystallization, even from the word as it implies, when you say fraction, that means it is separating more of those smaller particles that this one failed to separate. So when you have these different crystals in roughly equal amounts in a solution, so at a particular temperature, let's say you have crystals A, B, C, D. I can tell you that if you have this level of crystals, this crystallization process will fail, especially when they are of roughly equal amount. So the process you need to employ in order to separate these crystals is fractional crystallization. Because in fractional crystallization, what happens is that at a particular designated temperature, let's say 10 degrees Celsius, and this one is A crystal is very sensitive to this temperature. So when you cool to this point, let's say minus 10 degrees Celsius, when you cool it to this point, this one will be separated. Then you'll be left with B, C, D. So at a particular temperature of, let's say minus 5 degrees Celsius, this one will also be sensitive at this point and will be separated. That is the mode of separation of crystallization and what? Fractional crystallization. So I've been able to tell you when to employ crystallization and fractional crystallization. Fractional, that is when you have a smaller amount of smaller content with what? Roughly equal amounts. Then let's talk about distillation. In the case of distillation, it is used to recover solvents, from solution. It is used to recover solvents from solution when they have far apart boiling points. Far apart boiling points. And this process is employed in gin distilleries and water distilleries. Gin distilleries and water distilleries. In gin distillery to produce gin, and water distillery to produce water. Then the more accurate is the one that is known as fractional distillation. In the case of fractional distillation and distillation, the setup for both, which you have been taught in your previous lesson, the setup for both are the same, but the major difference is that this one has a fractionating column. It has a fractionating column where, because the mode of separation is when you heat a solution, and that in that fractionating column you have upper part has a lower boiling point, because this process separates mixtures on the basis of their boiling point. So in the fractionating column, you have upper region or upper part has a lower temperature, while the lower part has a higher temperature. So there is a LIBERIA condenser that is connected. For those of you that, and that is what you have learned in your previous lesson, there is a LIBERIA condenser. So when you heat, those substances evaporate, turn into vapor, and it separates on the ascending order of what? Boiling point. So as you are heating, when the boiling point correlates with the upper region, it will go into this LIBERIA condenser as vapor. And at a particular point here, water is introduced into this. What is the signal of introducing water into this lead condenser? It is to cool the vapor. So by cooling it, you know the process by which vapor moves to what? Liquid is what? Condensation. So when it cools the vapor, then the vapor when you introduce that water into this, and the vapor that is entering this at that particular temperature, critical temperature, will be cooled, and it will now be collected as what? Water. So you can see the difference between distillation and fractional distillation now. Fractional distillation separates two or more components, while in the case of distillation, you can only use it to recover solvent from a solution. So when you have two or more substances, definitely distillation will fail. So you need to resort to fractional distillation. And another condition for this is that the boiling point difference must be greater, must be more than 10 degrees Celsius. It must be borne in mind, because these are you can be asked that what is the major difference between distillation and fractional distillation. It has been stated here that one of the major difference is that this one separates two or more components, but this one can only be used to recover solvents from solution, and it is used in the making of gin and water. Also, this one, in the case of fractional distillation, there is what? Introduction of fractionating column, which does the actual separation. How does it do the actual separation? The upper part of that fractionating column has a lower boiling point, while the lower part